Hi there, Mrs McTaggart here, and in this video we are looking at a higher maths topic, and we are going to be looking at the double angle formula and the expansions for cos2A and sin2A. So before this you should have already done the expansions of cos bracket A plus B and sin bracket A plus B. Okay, so let's have a wee look. Okay, so in this box in yellow, these are the formulas you get given, and they're on the formula sheet, so there is absolutely no excuse for copying them down wrongly, but we still see it done all the time. So you'll notice if we give you sin2A, there is only one option for that one. But for cos2A, there's 3 different options. And sometimes, depending on the way the question's worded or the way it's going, one of these is easier than another. But they will all give you the same answer. When you come on to a further bit where you're doing trig equations, though, based on the question, the rest of the question or the rest of the equation will dictate which one you use, and only one of them will work out for you. There's one other thing I want to remind you of, and it's this thing here. It's the notation for when we're writing sin x all squared. So sin x all squared is written as sin squared x, and the reason is because you can't write it as sin x and then square it like that, because that looks like the squared is on the x. So the notation should be like this. So I technically say sin squared x when I'm saying it out loud, but I really mean sin x times sin x. So they also need to remember these ones from National 5, okay? So at National 5 you get told that sin squared plus cos squared equals 1. And from that you can rearrange these, and you can say, right, well, that means that sin squared x must be 1 minus cos squared x. And similarly, cos squared x must be 1 minus sin squared x. And then the tan x is just sin over cos. And similarly, if you had tan squared, it would be sin squared over cos squared. Okay, so they're National 5. Those ones do need to be committed to memory. So what I'm going to do is I'm going to do a quick proof of the double angle formula, and it says don't copy because this is the slides I use when I'm teaching it, and I would normally say to my pupils, you don't need to copy this, I'm just proving it to you, just look and listen, okay? So sin2A, remember that can be written as sin of A plus A, because A plus A is 2A, isn't it? And then if I expand that out, then that would be sin A cos A plus cos A sin A. Now sin A cos A and cos A sin A are the exact same thing. So basically I've got 2 of sin A cos A, which is what we had on the sheet before. So there's the proof for the sin one. I'm going to do the same for the cos one. So cos2A can be written in the same way as cos bracket A plus A. Now if I expand that out, that would be cos A minus sin A sin A. So remember, for cos the sign always changes. If it was a plus in the bracket, it becomes a minus. Now that really is just cos squared A minus sin squared A. So that was one of the proofs. From that, I can then play around with the cos squared and the sin squared. And I could say, right, well, we wrote earlier that cos squared was, so I'm just going to put a line there to show you that's your first one. So we can say that cos squared was 1 minus sin squared. So I just did that in the previous screen from the National 5 one. And then I can take away that sin squared A. So that is 1 minus sin squared x. Sorry, I've changed it to x's. They should really be a's. So sin squared A minus sin squared A. So that's 1 minus 2 of them, so 2 sin squared A. So that was your second expansion. And what I can also do is I can go back to this one with the cos minus the sin, and I can replace the sin. So I can say, well, that's cos squared A minus 1 minus cos squared A. And effectively what you've got is you've got a double negative there, so that becomes 2 cos squared A minus 1. So the things in the 3 boxes there are the 3 expansions that you had in that little yellow rectangle on the slide before. And that's the proof of them. But you don't need to be able to do that, you don't need to remember it, you just have to accept it and say, oh yeah, that's right, yep, that does, what she just did is right there. So let's go look at some actual examples. So here is my example 1, and I've got the formula up here in the corner because I need them as a constant reminder myself, I'm not going to lie. And they're up in the classroom wall, they're there, they should always be there, okay? So for question 1, it says write down a formula for sin 4a. Well, there isn't one for sin 4a, but there is one for sin 2a. So you have to think of another way to write this. Well, that's just the same as sin 2 times 2x. Yeah? Because 2 times 2x would be 4x. So basically, wherever I can go into my formula now for sin 2a and just put in a 2x there instead of the x. So wherever I see x, or wherever I see a, I'm going to put in 2x. So this would be 2 sin 2x cos 2x. And that's that one. This one here, cos 6x, can be written the same way. I can write that as a multiple of 2, so that would be cos 2 bracket 3x. So wherever I see a, I'm going to replace it with 3x. So I've got 3 options. So option 1 would say, well, that's cos squared 3x minus sin squared 3x. Or I could put it into the second one, and I could say, right, oh, that's 2 cos squared 3x minus 1. Or I could put it into the third one and say, well, that's 1 minus 2 sin squared 3x. What do you think? A wee bit confusing? So in this example, I have it expanded already and I need to try and put it back. I could go work out what, well, pi over 6 is 30, and I could work out what 2 times sin 30 times cos 30 is, and then prove it. But I'm going to go maybe do that in a minute. But this here looks very like the expansion up here in the corner. So this looks like I've expanded out 2 sin a, where a equals pi over 6. So this is sin 2 of pi over 6. My a has turned to pi over 6. Now, 2 times pi over 6, well, that's like 2, that's going to be pi over 3. So 2 pi over 6 simplifies to pi over 3. Pi over 3 is just 60. And sine of 60, using your exact values, maybe you know them off by heart, maybe you need to use a triangle. The triangle we use is this one. So sine of 60 would be opposite over hypotenuse, so that would just be root 3 over 2. But I did say I was going to prove it the other way. So the other way, just to prove it gives you the same, would be 2 times sine of 30 is 1/2. That's using the other bit of the triangle. And cos of 30 would be root 3 over 2. Now if you multiply all them, on the top you would have 2 times 1 times root 3. So you'd have 2 root 3 all over 4, which simplifies down to root 3 over 2. But we wanted to get you to do it this way. That's what I was kind of looking for, as a shorter way of doing it, using the sin 2x expansions. Okay, let's look at an example. So this is a more common example. So we're given that theta is an acute angle, and we're told that cos of theta is 1 over root 10. So that should be written as a fraction, but I can't always get that font in. So the first thing I'm going to do is I'm going to come down here to the bottom corner, and I'm going to draw a right angle triangle. And I'm going to call this angle here theta. I'm told that cos theta is 1 over root 10, so that means my adjacent is 1 and my hypotenuse is root 10. So I've got 1 and root 10. Now using Pythagoras, I can get that third side. I would do root 10 squared, which is 10, take away 1 squared, which is 9. Square root of 9 is 3, so my missing side is 3. Right, so for cos 2 theta, you've got 3 options to choose from here. You can use the top, the middle, or the bottom. Personally, I prefer the middle one. I think it's the easiest, but I'm going to do the first couple and just show you that it works out the same. So I'm going to rewrite cos 2 theta as cos squared theta minus sin squared theta first. And then just remember, cos squared theta is, that's just cos theta all squared. Cos of theta, we were told in the question, was 1 over root 10. So we're then going to have to square that. Sin of theta would be 3 over root 10. And we're going to have to square all that. Now squaring a fraction is just square the top, square the bottom. So we end up with 1 over root 10 squared is just 10. And then we have 9 over root 10 squared is just 10 again. So we have 1 take away 9, which is minus 8 over 10, which is minus 4/5 when you simplify it. I'm going to show you using that using the second formula as well. So I'm going to use the one where it is 2 cos squared theta take away 1. So that would be 2 times cos theta all squared. So 2 times 1 over root 10 all squared, then take away 1. So that would be 2 times 1 over 10, take away 1. Now that would just be 2/10, or 1/5. 1/5 take away 1 is minus 4/5. And then at this point we could go do the same again with the other one. We could do the sine one, which is to say, right, that's 1 minus 2 sine squared theta, which would be 1 minus 2 times 3 over root 10 all squared, which would be 1 take away 2 times 9/10, which would be 1 take away 18 over 10, or 9 over 5. And think about 1 as being 5/5. 5/5 take away 9/5 is minus 4/5. So there's all the different variations you can do for the cos2 theta. All give you the same answer. It's just up to you which you prefer. As I said, I think I like the middle one the best. So what I'm now going to do is I'm going to go do sin2 theta. So I'll do this on a separate slide. So sin2 theta expanded is just 2 sin theta cos theta. And from the side before, sin theta was 3 over root 10 and cos theta was 1 over root 10. So when we multiply them, think of that as 2 over 1 if you need to. The top numbers would be 2 times 3 times 1, which is 6. The bottom numbers would be root 10 times root 10, which is just 10. And 6 over 10 goes down to 3 over 5 when you simplify it. And generally that's a really bog standard question you get a lot. Sometimes you're given a triangle, sometimes you're just told one of your trig ratios, you're told tan x equals or sin theta equals, and from there you have to draw your own little triangle using your cos2A mantra from way back when, and then put them in and work them out from there. And then that's me. And what I would do is, if you were in math class, I would tell you to go to the TJ book. Now I know other textbooks are available, but this is relevant to the TJ textbook. Page 126 is enough to do now based on those examples. Thanks very much for watching.